So here the first question that you see is basically they have given us the displacement function, which is t square cos t plus 2t sine t, and that's valid from t between 0 to 5. The first question is you have to find out the maximum distance of the particle from origin. Now, displacement and distance, like first understand what's the relation between distance and displacement. So if you have the displacement, sometimes displacement can be negative, but distance has to be always positive. So if you draw the absolute value of displacement graph, you get the distance graph. Since it's a paper 2 question, I would draw this graph, which is on Courney graph, you draw x square cos x plus 2x sine x graph. So x square cos x and 2x sine x graph, which is out here. One more precaution you got to take is make sure calculator is in radian mode. Generally, lots of times when you do the calculations, your calci remains in degrees. So make sure it's in radian mode. So you press shift and menu and go on to the radian mode. So I'll just repeat again. So here, once you feed the graph, press shift and menu, and you go on to the radian here, like change it to radian mode. Also, I would recommend that keep your derivative on while you're doing a kinematics question. So keep your derivative on so that you can, if you have to find out any displacement to velocity function, you can just directly get the values if it is, if you don't have to find out the expression. So now suppose you got this graph. This is your displacement graph. To draw the distance graph, you just draw absolute value of this function. So press option, numeric, and absolute of function y2. You don't even need to type it twice. Just type out the function y2. In the meanwhile, you deselect the first graph. So deselect this graph. So you can see this is the distance function now. So gsolve and maximum if you do. So if you do gsolve maximum, you're getting this as a local maximum and this is your global maximum. So maximum distance that you notice is around 16.51, which is happening around 3.99 seconds. So this is how you kind of do the question. That is the first part. I will just share back the expression. I will just go back to the question. So that's the first part. Now the next part is to find out the acceleration of the particle, the instant at which it changes the direction. So how do I first find out where does the particle change its direction? So now what you're going to do is you're just going to first do one thing is you're going to draw the derivative function now. So you y2 is the function. Now if you know that the derivative of the displacement is nothing but the velocity function. So if you have the if you can differentiate this, just plot option cal and d by dx of the function y2. So y2 function, you can just type it out here, option cal and d by dx, you can see here. So you and here if I plot directly the second derivative, I'll not come to know where the particle changes its direction. So this is, you don't need to type an x value, just straight away plot the graph. So this graph that you're seeing now here is your basically the graph that is the velocity graph. Now to find out where it changes the direction, you need to first find out where the velocity is zero. So gsolve root c rule, the first root is here, the second root is 1.51, 1.519. So what you do is now you do one thing is you just draw the second derivative. So plot option cal and second derivative of the y2 function. So when I do second derivative y2 function, basically I'll just do it again, option cal the second derivative of the y2 function. So press exit and you'll see here y and 2. So now you see here that it is directly plotting the acceleration function for you. So if you have acceleration function, you can directly find acceleration from there, or I can even use this graph. So if I just trace, let's say trace at one point, when you do gsolve, let's say root, if I do gsolve root, automatically you're seeing that my first answer is coming as negative 8.91. That's a slope. So slope of velocity time graph is automatically negative 8.919. So that automatically is your acceleration. So you don't need to do again. But if you want to do that, like if you wanted to use the second graph acceleration function itself, now I'll just go back to the acceleration function. I'll deselect this and go to the acceleration function. Now, if you type out trace at 1.51, let's say 1.519, so automatically you can see dy by dx is coming around that point, which is, I mean, y value is negative 8.9. So that's how you kind of tackle the acceleration directly from acceleration function. Just put the time in the acceleration function, you get the acceleration. You don't even need to do any manual derivatives for all of these. You can see that we could do this question entirely on calculator. So here's the one of the very interesting question, that is where displacement graph has been given to us. So if your displacement function is 8t minus t squared, 8t minus t squared is this function which has been graphed here. So we can use this graph to understand the next parts. They have given certain other informations also. So the other information is the particle starts at the origin and comes back again at time 1t speed. So it's like you're starting from origin, you're coming back. After a certain distance, you're coming back to origin. So this is basically when it comes back, it is t equals to p. Also, they're saying that it changes its direction when t equals to q. So it changes direction means at this point, it is changing direction. Now remember that where it changes the direction, velocity function is 0 basically. V of t is 0. Then the total distance traveled by d is given by particle A is given by d. Write down the value of p. So first thing is that p is nothing but when it passes the origin again. So you can see here displacement is 0, where again displacement is 0 here. So I'm just going to solve for this time. So s of t here we have been given as 8t minus t squared. The question is 8t minus t squared, you can see that. So I'm just going to equate that to 0. So when I equate this to 0, I get basically either t as 0 or t is 8. So the t is 0 or t is 8. So we get t as 8. So basically this t equals to 8. Now second part is where it changes the direction. So where it changes direction, it means that velocity is 0. So first you find out the velocity function. So velocity function is 8 minus 2t. Equate this to 0. So you'll get 8 equals to 2t. So you'll get t equals to 4. So that's a t equals to 4. That's your basically the time where it is equals to, it changes the direction. So you can see that approximately at 4, it is coming back. Okay. After 4 seconds, until 4 seconds, it was moving probably to the right and then started coming backwards, and then displacement become negative. So it's like this. Suppose this is the origin, it went back, and it went forward, then backwards. So it is t. At this point, it reached here, and then it continues like this, according to negative displacement. The next part is find out the displacement when t is q. So when it changes the direction, the displacement at t equals to q. So you plug in t as 4 straight away because we have the displacement function. So 8 times 4 minus 4 square, which is nothing but 16. So 32 minus 16 is 16. So that's nothing but 16. Next up is find out the distance of the particle after 10 seconds. So after 10 second meaning, see it first it went forward for 4 seconds. It traveled a 16 meters distance. Then it came backwards 16 meters again. So total 32 meters. And now I'll just find out in this next 2 seconds, what's the displacement. So plug t equals to 10 in the displacement function and find out how much it has traveled to the left. So if I plug t as 10 here in the displacement function, it will be 8 times 10 minus 10 squared, which is 80 minus 100, which is negative 20. So it means that the particle has moved negative 20, means 20 units further. So this is 20, this is 16, this is 16. So in total, the distance travel, now when you say distance travel, so this distance travel will be always considered as all the length of the path. So 16 to go from here, 16 that is 32, and 32 plus 20, which is 52. So net distance travel is 52 basically. Now, next part is they're asking is, so that's C part. Then we got the D as well. Find out the value of the distance. So we got the distance as basically 52. I think it's both of the same answer should be same for C and D. So C is, C is basically 20 when at t equals to 10, basically they're asking. And final answer is D. So C is displacement basically, maybe. Yeah, so C is asking about, this is distance travel from the origin when it's t is 10. So from origin will be that 20 extra that we had calculated from t equals to 8 seconds to t equals to, let's say t equals to 10 seconds. This distance was 20. So that's what is the answer. And the net distance traveled is basically all, so 16 plus 16 plus 20, that's going to be 52. Next part they're asking is that there is a second particle where velocity function is given by 14 minus 2t. So 14 minus 2t is basically this, if I draw it. So it changes the direction, which is at 7. And then they're saying that at t equals to k, the distance traveled are equal. So what I'm going to do is this. So let's say this is t equals to k. This distance is going to be k minus 7, if you see straight away. So if I find out the area of this, the area of this is going to be 14 here. Area under the velocity time graph, is the distance travel, displacement. But I'm going to break this down and take care of the minus sign. So half base is how much? Basically 7 times height is also 14. So this is 7 times 7, that's 49. Plus, now this distance is basically half. Base is nothing but k minus 7. And height is also nothing but, if I plug excess k here, it'll be 14 minus 2k. And so if I equate this to 52, I'll get the value of k. So this is, let's say, 49 plus half. This is k minus 7. And this is basically, if you take 2 common and cancel with this, it'll be 7 minus k equals to 52. So it'll become k square, k minus 7. You can take minus common maybe. So this will become 52 minus 49. 52 minus 49, if you do, actually this y value is going to be negative. So you have to be careful now. See, since this value is negative, because if you put k straight away, that's how you're getting this negative as the answer if you solve for this. So actually this will be, instead of taking 14 minus 2k, you take 2k minus 14, because this height is basically, even though height is negative, when you calculate area, it will be always positive. So it'll be k minus 7 the whole square basically, because if you take 2 common and cancel, the k minus 7 and k minus 7. So k minus 7 the whole square equals to 52 minus 49. So 52 minus 49 is 3. So k equals to k minus 7 is plus or minus root 3. So k equals to 7 plus or minus root 3. So since I can't take minus root 3, because then it'll give me the lesser than 7 time, which is not possible. So the correct answer is k equals to 7 plus root 3. There was another way you could have done, was that you could have found out the basically the integral method. So this is the velocity function. So if you would have taken this absolute value graph, so this is 14 minus 2t. So integrate 14 minus 2t from 0 to 7, and plus this equation will be 2t minus 14. So integrate 2t minus 14, because distance is the absolute value of velocity. So I take the absolute value, basically this is t equals to k. So if I take this, it will be 2t minus 7. So this combined area should be equals to 52. 2t minus from 7 to k and equate to 52. When you solve for this, you'll notice that you're getting k equals to 7 plus root 3 itself. So that's going to be the correct answer. This is how you do this.